When you solve an equation in algebra, you use properties of real numbers that you've learned. Segment lengths and angle measures are real numbers, so you can also use these properties to write logical statements about geometric figures. So I'd like to review some of our algebraic properties of equality. So for real numbers a, b, and c, the following properties are true. Let's start first with the addition property. If I know that if a equals b, then when I add c to a, then that must be equal to b plus c. Likewise, in the subtraction property, you can see when we subtract c from a, then that must be equal to b minus c. In the multiplication property, if we multiply a by c, then we must multiply b by c. Essentially, what we're doing to one side, we do the other. If we divide by c, provided that c is not equal to 0, then we know that we will divide b by c. Now the distributive property, if we take a times the group b plus c, and you distribute a times b and a times c, then we should get a times b plus a times c. Likewise, if we undistributed that from out of the group, then that would also equal b plus c times a. Now the substitution principle is if we have a equals b plus c, and we know that b is equal to 3, then you can substitute that value in. Instead of a equaling b plus c, we would have a equals 3 plus c. So what this looks like in a two-column proof is if you were given an equation 2x plus 5 equals 20 minus 3x, we're trying to prove that x equals 3, then you can see that there are 4 steps to solving this equation. That must mean that there's 4 different reasons or properties that you can use to find that x equals 3. So let's start looking at what's given first. Number 1, 2x plus 5 equals 20 minus 3x is the given. We list statement or the reason number 1 as given. To go from step 1 to 2, we have to check what property was used to get 5x plus 5 equals 20. Because there was a negative 3x on the right side and you could add 3x to both sides, then that would give me 5x here. So adding 3x to both sides is which property? That's going to be your addition property of equality. So reason number 2, addition property of equality. Now, to go to the next step from 2 to 3, it looks like you could take away 5 from both sides. What property is that? It's going to be your subtraction property of equality. So then if you look at your last step, you are taking 5x minus 15 and you're arriving at x equals 3. So they must have divided by 5 on both sides. So which property would that be? That would be your division property of equality. So there we have filled out a complete set of reasons for this solved equation. This tutorial discusses additional properties of equality and congruence, such as reflexive, symmetric, and transitive. So for real numbers a, b, and c, the following properties are going to be true. And note that we have segment lengths and angle measures, which are real numbers. So the reflexive property would be such that you would have a would equal to itself, or b would equal to itself. In segment length, if we have segment AB, that would equal itself. If we had a measure of angle A, we know that it's going to be equal to itself. So in the real world, when you see numbers, if you have 1, that's always going to be the same amount as 1. It's kind of like looking yourself in the mirror. Once you see yourself, you know that you are just looking at yourself. Now the symmetric property derives from the term symmetry. For real numbers, if we had a equals b, then we would also know that b equals a is true. In segment length, if we have a segment AB, that would equal the same as measuring it from B to A, so AB equals BA. For angle measure, if we had the measure of angle ABC, it should be the same as the measure of angle CBA. In the real world, this is kind of like having half of a picture and then trying to find the rest of the picture by use of symmetry. Transitive property is when you have real numbers like a equal to b, and B equal to C, and being able to conclude that since A is equal to B and B equals C, that A must equal C. In segment length, we could have AB is equal to BC, and know that BC is equal to CD, therefore justifying that AB must equal the length of CD. In angle measurements, we could have the measure of angle A equals the measure of angle B, which in turn, the measure of angle B would equal the measure of angle C, and we could conclude that the measure of angle A must be the same as the measure of angle C. In the real world, this is like translating in languages from one to the next, and then ultimately being able to tell that those must mean the same thing. So like if you started with hello, and you went to Spanish, hola, and you went to French, bonjour, and then you went to another language, you could figure out that hello meant the same thing in another language, just as it did in Spanish or French, and so on.